And you want 4 terms for this one. So kind of breaking it down step by step. So 4 terms, it's called factoring by grouping, because that's what you're doing. You're going to group the first 2 pieces together, group the last 2. You're going to factor out a GCF, the thing that most of you forget about doing. Factor out your GCF from each of those. Once you factor this out, you should have a common factor. So the parentheses that are left, they should be the same. So then you'll pull that common factor out in front, and then whatever you have left goes in the second set of parentheses. This should not be a hard way to factor whatsoever. Okay, if you look at your big old flow chart, I know it's kind of crazy. We've focused on the 3 terms. We've done all of this. This is everything that you guys have ever factored, and the difference of squares. So then now we're looking at 4 terms. Group the first 2, group the last 2, factor out your GCFs. You should have a common factor or a common parenthesis, and then what's left over, and it goes down to your 2 sets of parentheses. So your end result for factoring will look the same, but how we get there looks a little different. Okay? So number 11, notice you have 4 terms. Still, just like every other factoring, do you have a GCF to start with in the entire problem? No. Okay. But I just want to make sure we do look for that, because if we do, we still want to pull that out. All right, so since there's 4 terms, we're going to group the first 2 and group the last 2. That is not factored, mind you. Don't stop there. That's just how we start, okay? All right, so then you look for, what's the GCF in the first set? X squared. So let's pull out the x squared. What do we have left? X plus 1. What's your GCF in the second set? -3. If that first one's negative, take it out. What's left when you take out a -3? X plus 1. Look at your parentheses that are sitting there. They're the same. If you did it right, you guys know how to do this. If you did it right, these should be the same. So we pull out that common factor. You pull out the x plus 1. It's kind of like you're factoring it out. What's left over if you take out the x plus 1s? And it's factored. Okay, let's kind of make sure you realize what you guys are excited, aren't you? Because you know this. All right, just make sure we know what we just did here. We grouped the first 2, grouped the last 2. Okay, anytime you have 4 terms, that's your go-to. I took out my GCF from the first set, factored that out. You take your GCF from the second set, factor that out. If you did it right, these 2 sets of parentheses should be the same. If they're not the same, at this point in the game, if they're not the same, you did something wrong. Okay, so whatever your common one is, we write that down. And then whatever's left goes in the second one. And that is factored. So then I just have to set it equal to 0 and solve, right? So x equals, what's it equal here? -1. This one, I'm probably going to have to write this one down. So then we'll add 3. And then what? Square root. So x equals. Good. How many answers do I have? I have 3, right? I got the plus minus. There's 1, 2, and 3. Your original problem was x cubed. So we know we have all the right answers. Maybe not the right ones, but we know we have enough answers. What do you think? Was that scary? That's not too bad, huh? This factoring is not bad. Yeah. But I'm going to teach you another one today that's not as easy as this one. That's okay. Start off easy, right? Warm us up a little bit. All right, so number 12, what do you want to do first? Yep, move it over. It's got to be equal to 0. So 4x cubed plus 4x squared. Are those like terms? Kelsey, are those like terms? Minus x minus 1 equals 0. Just making sure. They're both 4s. Based on your previous logic, I was just trying to make sure. Okay. All right, how many terms do you have? 4. There are 4 terms in there. What's the only way to factor with 4 terms? Your correct answer here is grouping. Good. So we group the first 2. Group the second 2. Do you guys notice I always include whatever sign that is kind of with that when I'm grouping? All right, what's your GCF in the first set? 4x squared. Okay, what do I have left when I take out a 4x squared? X plus 1. GCF in the second set? -1. What's left over? x plus 1. Do you have a common parenthesis? You guys see the common? So take out your x plus 1, and then what's left over? And it's factored. It's like magic, right? There it is. All right, set each one equal to 0 and solve. So x equals -1. This one I may have to do a little work to. Right? I'm not going to divide the 4 first. Add the 1. And then divide by 4. So x squared equals 1/4. Square root, remember top, bottom. Square root of 1. Square root of 4. So don't forget your plus minus, because you took the square root of something. So plus or minus half and -1. Where will that graph, like if I would graph that, where would it cross the x-axis? -1/2, +1/2, and -1? Yeah. How are we doing? Are we doing? Okay. All right, number 13. What do you want to do first? Good. Minus the 9. We got to set it equal to 0. So 2x cubed plus x squared minus 18x minus 9. Is there a GCF in the whole thing? No. Okay, so we don't got to worry about that. All right, so group the first two. Group the last two. GCF in the first set, x squared. What's left? Not just x plus 1. 2x plus 1. That's right. GCF in the second set? -9. What's left over? B plus 1, because you have the two negatives. Common parenthesis? Yeah, the common parenthesis, when we factor that out, is 2x plus 1. What's left over? X squared minus 9. We can solve from there. What's x equal here? This one we'll set equal to 0. Add 9. And then take the square root. So what does x equal? Good. You guys think you can try the next one on your own? Okay, try number 14. All right. So it's already set equal to 0. Was there a GCF in the whole thing? No. Okay, so don't worry about that. But there's 4 terms. Group the first two, group the last two. GCF in the first set? What's left over? GCF in the second set? Notice I'm going to write plus 5 just so I remember that that is a positive 5. And then what's left? Common parenthesis? What's left over? And it's factored. Okay? Then we solve. So x equals, and then x squared plus 5 equals 0. So minus the 5. So x equals? Perfect. How many times will that equation cross the x-axis? Once. Why not 3 times? There's an I, they're imaginary. It doesn't cross if it's imaginary. Good. The only other thing that you may see arise with this type of problem, just to kind of forewarn you, sometimes you go to group these, like if I group this, and if there's no GCF, if you're looking at that and there's nothing common to that, take out a 1. Does it change anything if you take out a 1? No, it doesn't. But the reason they want you to at least take out a 1, if you can't take out anything else, so that when you see common parenthesis and pull it down, I ask you what's left, you would need like an x squared, you need something to be here, Okay, so if, when in doubt, if there's nothing else, at least write down a 1 so you know to write that down at the next step. Okay? Questions over 4 terms? Okay. Then let's move into the next part. Let's talk about cubes. Cubes, yeah. I'll be honest with you, this whole method of the cubed method, what we're going to be talking about next, it is sheer memorization. Okay? Now, you can come up with your list of perfect cubes by using your calculator. Okay? I don't need you to memorize those. But the actual process to factor, it is sheer memorization. It's not going to be a guess and check. I might figure it out by guessing and checking. It ain't going to happen. You need to memorize how to do it. Okay? But first, let's kind of talk about what cubes are. Because you guys recognize perfect squares, or at least most of you do. But you probably don't recognize perfect cubes. I do only because I deal with them all the time. You guys probably don't. Do you guys know what is 1 cubed? It is 1. To cube something means to multiply it by itself 3 times. Now, I will allow you guys on your pink factoring flow chart, right along the top. Can I steal this for a minute? Right up here at the top, this is where we're going to be talking about. So right above here, or right down the side, you can make your list of cubes if you want to. That way you have those as easy reference. Marcus. I'm sorry? I have no idea. If there's any extras, they'd be in the basket. Okay. All right, so what's 2 cubed? That is 8. 2 times 2 times 2 is 8. 3 cubed? 27. 4 cubed? 5 cubed? 6 cubed? 7 cubed? 8 cubed? 9 cubed? 10 cubed? 10s are the easiest. 10 cubed, it has 3 zeros on it. All right, I'm going to be willing to bet most of you would not have recognized those as special numbers in any way, shape, or form. You would have? Some of you may have. You've been through this class. You should recognize those. All right. Probably the most common you'll see a lot more often are like, 1 through 5 cubes. You'll recognize those. So like if I had asked you what's a square root of 64? Square root of 64, what would you have told me? 8. Why 8? Good, right? 8 times itself twice, hence squared was 64. So if I ask you what's the cubed root of 125, it's 5. What's the cubed root of 27? It's 3. What's the cubed root of 729? 9, because 9 cubed gave you that. Okay? You need to be able to recognize how that works. On your calculator, can you type in the cubed root of a number on your calculator? Yeah. If you no, the caret will cube it, not take the cubed root of it. If you were using the graphing calculators, hit the math. I think it's underneath the math button. Where's my calculator? I want to make sure I'm telling you the right thing. Yeah, it's underneath the math button. It is option number 4. So if you're using the graphing calculator, hit math. It's option number 4. We'll pop up the cubed root. If you were using the other kind of calculators, you would have to hit, just make sure we're clear, on the regular calculators, you would have to hit the number 3 to tell it cubed. Then you'd have to hit second. And then you have to hit the caret button. Because above the caret button, it's got this little like X looking thing like this. This is you telling, hey, I want the cubed root. It's telling you I want this little root symbol here to be a 3, the cubed root. So like if I typed all of this in and I type in 27, it will tell me 3. Like if we're trying to take it backwards. If you want 3 cubed, yes, you'd hit 3 caret 3 and then it would tell it to you. But it works its way backwards. Right, but why would you want to go through all those steps in the graphing one when I could hit math 4 and it's right there? That's what I just said, Ramon. I told you. Ramon. trying to make your life easier, Ramon. Don't make it harder. You're right. All that's under there. Because there's 4th roots and 5th roots and 6th roots, which you would need to use that. But that's not until we talk about chapter 6. Oh, we'll get there. 5. We're going to go from 5 to 8, and then we'll come back to 6. Because 8 has more factoring in it still, and 6 is not as much factoring. So while it's familiar and fresh in your mind, we're going to move on into it. That's why we're swapping that around. Okay, so cubes, start to recognize these numbers when you see them. Those are your perfect cubes. All right, so here we go, guys. Again, this is a sheer memorization way of factoring. This is not guess and check, play around with it, figure it out. You're going to memorize it. All right, so with 2 terms, that's what we're talking about. Look at your flow chart. Notice it says 2 terms. Below there was difference of squares, and then above it says the cubes. Okay, so this is when I have 2 terms, and is it easy to recognize if it's squares or cubes? It should be. If it's squares, difference of squares, you're going to have an x squared. If it's cubes, you're going to have an x cubed. Yeah, they're easy to recognize the difference. So when we're looking at this, now difference of squares was only a subtraction sign. But for cubes, you can have a plus sign or a minus sign. It doesn't matter. Okay, the sign makes a difference when I'm factoring it, but as far as can you do it or not, yes, you can, whether it's plus or minus. The equation, what it originally looks like? Like this. Do you know whether or not this factors? Is this difference of squares or difference of cubes? Cubes. Cubes. Yeah. Yep, no, we're talking about the original problem that we're going to have to factor. So when you're looking at this, you're going to have 2 terms. This could be a plus or minus. For cubes, it doesn't matter. You're going to recognize there's going to be an x cubed in there, or you'll pull out a GCF and you'll have an x cubed sitting there. Both of your numbers, what are you noticed by both of these? Look at your list. They're perfect cubes. Yeah, they're both perfect cubes. So when you're recognizing can you factor it, you have 2 terms. You have an x cubed. Watch for GCFs. But after you pull out a GCF, the numbers you have left should be on your list of cubes. Okay? Are we okay? 2 terms, plus or minus, don't care. Cubed, both will be on your list of perfect cube numbers. Okay? Now, the part of factoring it, the sheer memorization. If you look up here, actually I can break it down right here for you. The original problem, you're going to take the cubed root of both numbers. That goes in your first set of parentheses. So just like when you had difference of squares, right? Like we had 4x squared, minus 25. If I asked you to factor that, right? You set up your parentheses, you filled in your signs, one was plus, one was minus, and you took the square root of both of these, right? Okay, and you filled that's what you filled in. Same idea. I'm going to take both of my numbers, I'm going to take the cubed root of them. I'm going to fill them in. So, like on this one, kind of break this down one step at a time here. If I look over here, just filling in the numbers here, we'll talk about signs in a minute. What's the cubed root of 27x cubed? 3. 3x. And what was the cubed root of 8? It was 2. Those were the first numbers we have to worry about. Same way we did with square roots, we filled in the square root of them. We do the cubed root. Now let's take a little time out from how all these numbers work. Let's talk about your signs, because that's usually the first thing we fill in. We need to remember soap. All right, you go to the bathroom, wash your hands, and what should you use? You better use soap. Come on, you guys have known you've been sitting in the bathroom, public bathroom, you hear somebody come out of the stall, and they just walk on out. Makes you want to vomit a little bit, right? Okay, please use soap. And what does SOAP stand for? It's your signs. It is the same sign, opposite sign, and then it's always positive. Because when you're factoring these, you got 2 sets of parentheses, but that second set actually has 3 numbers in it. That's not normal. Everything we factored, that's never happened. Ours only have 2 numbers in them. This one's different. So you're going to use the same sign, right? So my original sign was minus, so I'm going to use the same sign. Opposite, and then the last one is always positive. So that's the first thing you would fill in as your signs. It's based off your original one. I'm going to go same sign, then I'm going to flip to the opposite sign, and this one is always positive. Same, opposite, always positive. That's what SOAP stands for. I like stupid ways to remember things. All right, and then you're filling in, first numbers we filled in, we just took the cubed roots of those, fill those in. Once you did that, I don't even need this anymore. To finish filling in the second part, it's sheer memorization. It's square, multiply, and square. And it's based off of these numbers that you filled in first. So what is 3x squared? 9x squared. So we squared. That's where this one came from. And then you multiply these together. Don't worry about the sign because I already filled them in. So just 6x. And then the last one square again, we square this one. 2 squared is 4. That's factored. There's no guessing, there's no checking. I mean, could you check it? Sure, you can multiply it all back together. But if you follow the pattern, it always will work. Okay? So literally, when you're looking at these problems, let's make sure we're okay here. You have two terms. Okay? It has to have an x cubed in it. And both of your numbers have to be perfect cubes on your list of cubes that we just talked about. Okay? Should you look for a GCF first, though? Always. Always, always, always. Look for that GCF, take it out. Okay, so whatever you're left with, both your numbers will be perfect cubes. Plus, minus, doesn't matter. Doesn't matter. Doesn't matter. And I'm going to have x cubed. So we're literally going to start by taking the cubed root of each of them. And then it's square, multiply, square. Square the first one. That's how I got 9x squared. You multiply the two of them together, 6x, square the last one. That is factored. Let's try another one. That is factored. That's not solved. Oh, of course we are. All right, so again, on your flow chart, we'll now have taught you everything on your flow chart. So if you have two terms, don't be thinking anything else, but if it's squared, if you have an x squared, it's here. And if it's x cubed, it's the harder one, but you got to memorize that pattern. All right, so 14, x cubed plus 27 equals 0. So again, always want them to equal 0. I'm going to actually solve this one after we factor it. All right, I have two terms. Do you have an x cubed? Mm-hmm. Are they both of your numbers, both parts, are they perfect cubes? Yeah. Cubed root of x cubed is 1x, so that one's okay. And 3, yeah, so they're both perfect cubes. So let's set up our parentheses. Remember, the second parenthesis is a little bit longer because it's going to have 3 terms in it. Let's fill in your signs. Remember to always use SOAP. It's really gross if you don't. So SOAP tells you your signs. So we're going to use the same sign. So the first one's going to be a plus, and then an opposite, and then always positive. Same as the original problem. Opposite, and then always positive. Questions so far? Then we're going to fill in our numbers. We start by taking the cubed root of things. What's the cubed root of x cubed? 1x, or just x. Cubed root of 27? 3. Do I need the original problem anymore? Nope, because everything else is based off of this right here. Right? Remember, we're going to square the numbers, we're going to multiply them together, and then we're going to square the last one. So what is x squared? X squared. Multiply them together. What's x times 3? 3x. Square the last one. That is 9. That is factored. And again, it's a matter of you got to memorize that. Questions so far on the factoring? Now we need to solve. What's the first answer? -3. All right, well, that don't seem so bad, right? The second part, that will never factor further. Did you guys hear me? Never, ever, ever will that factor further. So if you know it doesn't factor, what do you have to use? Quadratic formula. Every single time. You guys got that? I don't want you to waste time. That will never factor further. Ever. Ever, ever, ever. You will always have to use quadratic formula. So x equals -b, so 3, plus or minus square root b squared minus 4 times a times c all over 2 times a. So 3 plus or minus radical negative 27 all over 2. So 3 plus or minus 3i radical 3 all over 2. Simplify any further, all three numbers? Nope, I'm done. How many times did that one cross the x-axis? Once, because those other two answers are imaginary. All right, so once you memorize the pattern, how is it for solving? Yeah, it's not bad. The first one will always be real easy, and then the second part, what do you always use? Quadratic formula every single time. All right, let's look at 15. Wow, those numbers are huge. So if I'm looking at that, I see two terms. I see an x cubed, so I'm thinking, all right, it's that sum and difference of cubes, right? Are 128 and 1458 on your list? So what's that tell you? There's a GCF in there. What number goes into both of those? 2? At least 2? If I pull out a 2 and they're cubes, am I good? Let's pull out a 2 and let's see what we got. What do you get? 64x cubed minus... Oh, come on, you guys. I can do that in my head. There we go. Are 64 and 729 on your list? Yes. So are we good at the GCF then? Yeah, they're on my list now. I'm good. All right. So let's go ahead and set up our parentheses, just like we always do when we factor. Let's fill in our signs. That's always our first step. So what are my signs? Good. Same, opposite, always positive. All right, what do I fill in next? The what? Not the square root, but the cubed root. Cubed root. Be careful, because some of you have like, oh, 64, the square root of that's 8. You're right, it is, but we're doing cubed roots. So that'd be 4x. Cubed root of 729 is 9. So that's your first step, fill in the cubed root of both of those. And then it's square multiply square. So what's 4x squared? 16x squared. Multiply 4x times 9. 36x, and square the last one, 81. That's factored. That's just sheerly me knowing the pattern and plugging numbers in. Just like quadratic formula, right? You just memorize the pattern of it and keep using it. All right, so we know that x equals, does the baby brother matter here? Nope, there's no x with him. Don't care about him. Don't care. Here? What do I get here? 9/4. And this one I have to use quadratic formula. It will never, ever factor. It may look like it will, but it won't. I promise you. All right, so x equals negative b. Oh, these numbers are going to get big. Plus or minus square root b squared minus 4 times a times c all over 2 times a. The numbers got big. So x equals negative 36 plus or minus, what do we got under there? 3,000, 888 over 32. This is where most of you on your own would have died a little bit and probably been like, I'm out. I must have done something wrong. It's okay. The numbers get a little big sometimes. Sometimes. Would you be astounded if I told you I know what that's going to simplify to without ever touching a calculator? And that's not just because I'm good with mental math. Do you want to know my secret? It does link together. It's going to be 36I radical 3. Are you impressed that I could do that? I did all that in my head. Are you guys impressed? Did I really do all that in my head? No, I didn't. Look at this. 3 plus or minus 3I radical 3. Negative 36 plus or minus 36I radical 3. Do you see how these numbers are the same? Do you see how there's an I and a radical 3? These numbers are the same, and an I and a radical 3. It always simplifies that way. Whatever your b value was here, it's going to be bi radical 3 on the top. It's always the same. That's why it almost kills me to write all of this down and write all of this down when I know it's going to end up right here. If you recognize and can use the shortcut, by all means, use it. If you're like, wait, what? I got to memorize one more thing, then just use the quadratic formula. It always works. Okay? But I can simplify all three numbers. It can be divided by what? I heard a 2, I heard a 4, I heard an 8. You're right, 36 does not go by 8. So 4. What's 36 divided by 4?
-9.
So -9 plus or minus 9I radical 3 all over 8. I tried to share my secrets for quick math there, guys. If you can memorize that and it makes sense to you, use a shortcut. If not, it's okay. Quadratic formula will always get you there. Yes. One, 2, 3. Oh, good question, though. Yep. Don't forget that plus minus is 2 answers. How many times will that cross the x-axis? Once, because the other ones are imaginary. Yeah, for the cubed ones, not all cubic equations only cross once, but the sum and difference of cubes cross once. All right, do you guys want to try one on your own? Try it on your own. Try 17. All right, guys, so 17. It's already set equal to 0. 2 terms. Notice right away 2 terms. You only can go squares or cubes. This one is cubes because you have an x cubed on there. All right, so let's set up our parentheses. We fill in our signs. So same, opposite, always positive. All right, and then we take the cubed root of each number. So the cubed root of 8x cubed is 2x. Cubed root of 1, 1. And then to fill in the other parts, square, multiply, square. What's 2x squared? Multiply 2x times 1. And 1 squared. So there it is factored. Okay? So if we go to solve, x equals -1/2. And then how do you solve the other part? Should I factor it? You can't. Don't waste your time. It will not factor, I promise. All right, so x equals -b, be 2, plus or minus. It will become 2I radical 3 all over 2 times a, which is 8. All right, real quick, time out. If you didn't recognize the pattern and you went through quadratic formula, simplified your radical, did you still end up there? Yes, you will. All right, and then I can divide all numbers by 2. Do I need the 1? 1. Thank you. If we can add or subtract, that one's necessary. Do I need the 1 here? No. I radical 3 all over 4, because I'm dividing them all by 2. That's okay. Totally fine. Quadratic formula always gets you there. I'm just lazy mathematician. I like shortcuts. I know. I'm lazy. No, it's always -b, so it just depends on your problem. All right. How about number 18? What do you want to do first? Subtract 16. 54x cubed minus 16. All right, I'm looking at them like, all right, two terms. Cubes or squares? Cubes. Are 54 and 16 on my list? No. What do I have to do? Good. It's got a GCF of 2. What do I have left? 27x cubed minus 8. You guys with me? I'm just taking out a 2. That's old school. I just took out a GCF. That's all I did. Now, are 27 and 8 on my list? Yes. So I know now it works. Signs? Same, opposite, always positive. Cubed root of 27. It's going to give me a 3x. Cubed root of 8 is 2. And then we will square, multiply, square. What is 3x squared? 9x squared. Multiply 3x times 2. And 2 squared. How are we feeling about the pattern? You doing okay? All right, so then when we solve, baby brother? Don't care. All right, but x equals 2 over 3. How do I solve this one? I have to use quadratic formula, right? Okay, so negative b is going to be negative 6 plus or minus over 2a all over 18. Again, can you just use the quadratic formula there? Yeah, that's what I'm doing. I just know the shortcut. I know what's going to happen. Simplify. All of them can be divided by 6. 6. So negative 1 plus or minus I radical 3 over 3. How are we feeling? You see why you have to memorize, right? You're not going to guess and check your way through that? That'd be awful. All right, let's have you guys try. Let's go 19. Let's skip 16. We'll just skip that one. Let's have you guys do 19. All right, here we go, guys. Last one. You guys ready? All right, so when we set it equal to 0, x cubed plus 343. Right away, in your mind, you should be looking at this and you should be going through the thought process because eventually all these factoring problems are all going to be together, like on the quiz on Thursday. So when you're looking at these problems, you're like, all right, two terms, cubes or squares? That's cubes. There's an x cubed. Okay, should be easy to recognize. Is 343 on your list? Yes. So that means I don't have to worry about taking anything out. Set up your parentheses. What are your signs? Good. Same, opposite, always positive. Cubed root of x cubed? Cubed root of 343? Square, multiply, square. So what is x squared? Multiply x times 7. Square the 7. Ta-da, factored. Now we need to solve. So x equals, and then x equals negative b plus or minus all over 2 times a, so just 2. Anything simplify? Nope. And if you went full-on quadratic formula, you should have still ended up right there. How are we feeling? Okay, you guys don't seem too scared? Yes, the rest of the time is for homework. That same packet that you guys were doing, what are there, 36 questions on there? Yeah, 25 to 36. Yep, it's the same packet that you were working on before.